Okay, so here we have the function y equals the natural log of x over the interval from 1 to 2. So if you look at the natural log function, well, for one thing, it crosses the x-axis at x equals 1, and then looks approximately like this. In here, it's saying rotate about the y-axis, so you definitely need to pay attention to, is it rotated about the y-axis or the x-axis? So this one being rotated around the y-axis means that when you go to find the radius, so the general formula for finding arc length is you integrate 2 pi, then times the radius, and then times the arc length. And the radius needs to be measured from the axis of rotation out to the function. So that means go from the axis of rotation and then go over until you hit the function right here. And this value, if you look down at the x-axis, is going to be somewhere between 1 and 2. And I don't know what it is, so what we do is just say, well, that's an x value as x ranges from 1 to 2. So that is going to be the radius. If this said rotate about the x-axis, then we would have to go from the x-axis and go up to find the radius, in which case that would be the function natural log of x. But in this case, the radius is just going to be x. Okay, then for arc length. Well, for arc length, for one thing, we need the derivative. And of course, the derivative of the natural log of x is 1 over x. And in general, this is going to look like integrate from 1 to 2, the 2 pi, the radius is x, and then for arc length, that is the square root of 1 plus the derivative is squared. So this needs to be squared. All right, and then that is what we need to integrate. So when we've got these square roots, that means we need to do a little bit of algebra. So this is 1 over x squared. And let me just recopy the rest real quick. So we've got that this part is 1 over x squared. And then we need to be able to add these two things, so I need a common denominator. So the 1 can be changed into x squared over x squared. And then I can add these two together. So we've got integrate from 1 to 2, we've got the 2 pi, the x, and then a square root. And when you add the two fractions together, the numerator is going to have x squared plus 1. And then divided by the common denominator x squared. And then it just so happens that this, when you take the square root of it, is going to be an x in the denominator, and it's going to cancel this x. So all that's left is 2 pi, and this will become an x, which cancels this. So all that's left is the square root of x squared plus 1. All right, now when you look at this, u substitution is not going to help, so it would be trig substitution. When you do trig substitution, this one becomes secant cubed, which is in itself probably about a 10-minute video to do that. That's the reason there's a little star right here saying that you can use your calculator after you've set up the integral. So now let's see what this equals by using the calculator. So let me get it to focus on the calculator real quick. So we've got 2 pi, and then there is the square root of x squared plus 1. And then I will just go to zoom standard. So seeing the picture right now, for one thing, it's not going to be that graph. It's a different graph. You don't really have to see it. If you do, that's nice. Let's see. Okay, so I can see part of it, that's fine. And then calculate number 7, the integral from 1 to 2. And then that turns out to be an 11.373.